Welcome to ERDC Live. I am your host, Shelley Tingle with the U.S. Army Engineer Research and Development Center. Today we welcome a distinguished panel from across the Department of Defense to discuss the development and use of sustainable materials in military construction projects and beyond. Sustainable materials will play an essential role in ensuring our nation and military meet current construction and development needs, while at the same time mitigating the negative impact construction technologies and techniques have on our climate and environment. Today with us online is Kelly Olson, Sustainable Buildings Lead on the DoD's Climate Action Team. In person with us is Jonathan Petry, also with the DoD's Climate Action Team, Ed Citzler with the Sustainable Senior Architect for the U.S. Army Engineers, Corps of Engineers, and Dr. Robert Moser, ERDC's Senior Scientific Technical Manager for Materials and Structures, and Dr. Stephanie Wood, a Research Civil Engineer at ERDC's Geotechnical and Structures Laboratory. Thank you all for joining us this morning. We're going to jump right in and get started. Kelly, the DoD's Climate Action Team works to address challenges of increasing energy and resilience and security and reducing the greenhouse gas emissions contributing to global warming. How does research and development in sustainable materials align with the climate team's priorities?
Hi, everyone. Yeah, research and development are essential because we can't put something on the ground, we can't promote something, we can't design it, we can't construct it if we don't know that it's going to work. So research and development is that first step in proving a concept and proving that it meets all the other requirements that DoD has for its construction materials.
And so what are some of the drivers that you are seeing that, that are behind the Sustainable Materials Program?
A couple of the drivers are lowering the embodied emissions in the materials that we're using. We also have these drivers of, as I mentioned, all these other requirements. For example, with concrete, we want to lower the carbon in concrete, but we also need to meet strength requirements, structural strength requirements. So the driver to lower carbon in that concrete has to be compared with all the other requirements that we have. And that trade-off is not as simple as a lot of people might like to think that it is. It requires an evaluation that is multifaceted. We have to think about maybe where that building is, the purpose that it serves, the use, the longevity and the duration of occupancy in that building. So it's not a one-size-fits-all solution. And that's why the drivers we can often think of as being across space, across time, across use, function, and across the individuals who are going to occupy these buildings.
Jonathan, could you discuss the goals of this effort, specifically those dealing with saving energy and mitigating the negative impact on our climate that traditional construction and materials have?
Yeah, so I think one of the keys for Department of Defense is resilience. And we see that strategy kind of twofold. One is adaptation to changes that are already baked into the changes that we see in our climate, and mitigation to avoid any consequences that we can. And so through materials, you know, for a long time, you mentioned energy, we've talked about operational carbon, we've talked about operational environmental impacts, we've talked about, you know, definitely since the 70s, passive design and solutions through orientation of buildings and through thermal mass and how we create those. But that only affects 60 to 70% of the impacts that a building might have during its entire life cycle. And so now you're seeing this focus, and maybe some of the drivers are the NDAA, executive orders, things that we're seeing in the industry, greater transparency about materials and about their impacts, and increased ability to model those impacts and to see what that might do as we try to drive down our barriers to resilience. So through the process of focusing on low carbon or low emissions or lower environmental impact materials, we're learning a lot more about our supply chain as well too. And we're going to be able to look further down the line, just as we're modeling climate impacts over 80-year periods. We're starting to look at what are the impacts of our materials, because when we build a building or when we put a pavement in the ground or we do something, we're making decisions that could last for 40 to 100 years. So thinking through that now, modeling that, doing that all to reduce those embodied impacts will maybe reduce the amount of offsets we'll have to do to get to a maybe carbon neutral or emissions neutral type DoD economy.
All right, so thinking beyond the immediate problem and thinking how this is going to impact things 70, 80 years, probably long after we're all gone. And so that's really important. I want to remind our audience that if you're watching live, we will be taking your questions. And so while we have these leaders from across the DoD, be thinking of the questions that you want to ask them, and we will be asking those shortly. USACE is known for its construction projects, particularly those on our nation's military installations. How will the adoption of sustainable materials and better construction techniques improve USACE's mission?
I think that it all starts with innovative materials and the research that we do with those materials. I think moving forward, we can reduce the environmental impacts through research, then through design, and then implement all of that through construction. So I think it will change how we do construction, how we review construction and inspect construction, and the adjustments that we make. But I think it's, as a whole team, we need to support those, both with the research side, the design side, and so forth, moving into the construction side, where we can actually see what's being built and how that happens, and how we have changed the materials that we use and the technologies that we use.
And so do you see this as a shift of the traditional steel and concrete? You know, that's what I think of when I think of construction is steel and concrete. Do you see a shift in that in the future?
I believe we will still be using steel and concrete. There's new concrete mixes out there. There's new innovation that still reduce the environmental impact of concrete, and we use high amounts of recycled steel. In our UFGSs, we require, I believe it's like 90% recycled steel. So as we keep improving the materials that we use during construction and having sustainable materials in our UFCs and our UFGSs, I think those materials will still be around. Now, utilizing heavy timber or CLT, I believe will also probably increase also. But those are all kinds of materials that our designers can utilize and that we have utilized in the past.
Very good. Robert, we have heard a lot about reducing the amount of greenhouse gases and the carbon footprint of traditional construction materials. What types of research is ERDC conducting to better reduce carbon emissions or improve carbon sequestration?
All right, thanks Shelley, and thanks everyone for participating this morning. It's exciting to talk with y'all. So we have research activities here at ERDC and in concert with many partners on a wide spectrum of technologies, and I think are really looking for opportunities to partner more so in those areas. So in the near term, some of the things I'm the most excited about, and we can probably talk about in a little more detail, are ways that the R&D community is supporting pilot projects where in the near term, across the department, starting with the Army and the Army Corps of Engineers, but even working in concert with our tri-service partners in the Air Force and the Navy, demonstrating our ability to use and promote the use of sustainable materials across structural systems, architectural systems, building envelopes, everything that goes into a facility project is something that we're working towards right now for projects that are going to break ground next year and into the future. So we're really excited to bring our research community and technologists into the fold, working with our practitioners to do that. And so that's getting at some of the near-term requirements and goals. In the mid to long term, those are things where we're working in the research community, both military and civil. And so we have new activities kicking off this fiscal year, a lot of those in alignment with the Assistant Secretary of the Army for Installations, Energy, and Environment. And we're trying to look at kind of what are the next phase of implementation of technologies and the knowledge gaps that we need to fill in those materials and life cycle analysis procedures, ways that we collect and analyze information. And so those materials include lower carbon forms of cement and concrete products, asphalt materials that would go into paving projects, and then potentially the use of things like mass timber or other kinds of bio-based building products that have low energy manufacturing processes. And so what are the unique knowledge gaps that we've got to fill in those as well? The final part of that is having, I would say, materials agnostic ways that we can analyze them. So life cycle analysis, collecting information on environmental information about those materials, and then with support from our stakeholders here and leadership is how do we get that across the finish line and onto the menu for practitioners to use? And so that specification updates, criteria updates are key to that as well. And so that's what we're working on the military side of our portfolio. On the civil side, we also have unique new initiatives in R&D starting, I think, last fiscal year, and Dr. Wood can speak to some of that. We have some starting next fiscal year as well that we're really excited about. And so those are going to look at some of the, I would say, the really unique challenges that we have in the Corps of Engineers for building, mass concrete mega projects and large steel structures. How are we going to meet some of the unique objectives in those mega projects and also work towards improving sustainability? And so there's some emphasis there that Dr. Wood can speak to, definitely better than I can. And then the final area is partnerships. So we're heavily working, I think, within the Army, across the DoD, and with our other federal partners on, because there's initiatives like this in every agency you can think of, and support from the private sector, from venture capital, and across the world. And so there's a lot to keep track of and a lot of things to engage in. So whether it's the SBIR STTR program, it's the Army's X-Tech Search program, there's all kinds of opportunities for new technology to get into the fold. And so we're trying to, I think, work as part of this whole government approach to addressing sustainability and resilience, leveraging opportunities, leveraging new technologies where there's investments in other agencies or other programs, and then looking at ways that, we as ERDC, we as the Corps of Engineers, what are the knowledge gaps that are unique that we need to fill to get some of those technologies across the finish line and into our military and civil projects. So,
very good. So for the audience, if you have just now tuned in, you are watching ERDC Live with some of the DoD's leaders in sustainable materials, and we will be taking questions from you shortly. Stephanie, one of the largest carbon emitters among construction materials and techniques is the making of concrete, a material used quite a lot in traditional construction and in use cases military and civil works projects. What are some of the challenges in curtailing the amount of carbon in the creation of concrete, and what research is ERDC doing in this area?
Yeah, so I do a lot of work on the civil works side. So we're talking about mass concrete, think of navigation locks and dams. And that's kind of a leading area, I guess, because for a while we've been traditionally kind of more sustainable with concrete on that side, because we do things like use lean concrete, so we're using less cementitious material in our concrete mixtures. So a lot of the CO2 comes from the production of Portland cement. So it's the fuel that you need to operate the kiln, and when you calcine the limestone, that emits CO2. So the less that we can use in the concrete, the more sustainable the concrete. We've been doing that for a long time. We've also been using alternative cementitious materials or supplementary cementitious materials, SCMs, like fly ash. We've been doing that for decades, and that cuts down on a lot of that. But the reason that we've been doing that for so long is not just to use some of those waste materials, but also to combat some of the things that we are uniquely challenged with in civil works that we don't necessarily have in other applications, like the heat of hydration. As cement starts to cure, it's exothermic, it emits heat, so we have to control that heat to prevent cracking. If we get cracking in our structures, that's less sustainable, it's less durable. We've been doing that for a long time. And then we have concrete deterioration mechanisms like alkali silica reaction, so fly ash kind of prevents that as well. So we have to have that kind of, it has to control heat, it has to control deterioration mechanisms. We have to do that at the same time that we work with a lot of the admixtures that we put into mass concrete.
And so there's a lot of things that you're already doing.
Yeah. And right now we have a project where we're looking at alternative supplementary cementitious materials because our supply of quality fly ash or fly ash that you could use in concrete is being reduced because we're not relying on coal combustion for electricity, which is a good thing. But we do have a shortage where we're using that a lot in our mass concrete. So now we've got to find alternative materials to replace that and do what we need it to do. So we're leading a research project right now that started last fiscal year, where we're looking at things like recycled glass that may not work well for mass concrete, but it could work for other applications, structural. We're looking at natural pozzolans, using those to do what we've asked fly ash and slag cement to do for so long. And then we're looking at some materials that you may not think to use in concrete, some things that haven't been tapped yet. And in the interim, we're looking at things like reclaimed fly ash, where it's already been landfilled and we can harvest it. And it might take a little processing or it might take a little more processing to get it to where it can be used in concrete. So we're doing a lot on that end, and it wasn't really with the driver of sustainability so much as we now have this issue that we have to tackle. Mm-hmm. But it fits in with the rest of the drivers that we're all facing.
Yeah, so it's a win-win, something you're already looking into, but also it addresses some of the sustainable issues that you want to look into as well. Kelly, while we know that there are tremendous benefits in incorporating sustainable materials in our construction projects, what are some of the major obstacles ahead for this program?
Yeah, well, it has been noted before by some of the others. One of them is just lack of proven concept. When something is so brand new that we don't have the great work that ERDC is doing or industry standards behind it, we don't know that it's proven. We also need to think about procurement and supply chain, as Jonathan mentioned, and the long process of getting government projects built. Unfortunately, we have a lot of phases when we have government construction projects, and at every phase, there can be bottlenecks that prevent or prohibit or just deter the use of these sustainable materials. So one thing we like to think about is that we're not promoting a specific material, but rather we are allowing a wide range of solutions. So the more prescriptive we get, the harder it can be to get what we want. We also have some obstacles in the government because we have to value fair play and the ability for many people to supply the products that the government procures. So we can't specify something that has no competition. For the most part, I should say, there are some programs and prototype programs, different ways to make that happen. I don't want to scare anyone off of that. But when we're thinking large scale, kind of normal military construction, for example, we can't have this novel new product without any competition in the market because the government can't choose winners. So we really want to select products where there's a wide range of options to choose from. And if the product is too novel, there's not going to be enough producers in the market. And so that is something that prohibits us from selecting it. That's why it's so important, as Dr. Moser said, to have those specifications that allow for the specification updates that allow for a lot of different opportunities so that when we work with private sector partners, they have a wide range of places that they can go with their design, with their construction, with their procurement. So that's just one or two examples of obstacles.
So it seems like one of the obstacles would be some knowledge management or communication with industry and academia. So can you tell us a little bit about how you're partnering with academia or industry in promoting some of these changes?
Yes, I'm not sure I have the best answers on academia. Maybe someone else can take that portion of the question. When it comes to some of our other partners, we do try to work closely to break down these silos between different groups. Jonathan, for example, can speak to the work he's doing with the Buy Clean initiative, which is really spearheaded by CEQ and GSA. And so we're trying to tap into those networks so that we're not reinventing what we're doing time and time again. We're trying to use the research that already exists. We also rely a lot on the federally funded, get this acronym wrong, FFRDC, Federally Funded Research and Development. Oh no, you're putting me on the spot. So we rely a lot on them for the studies that they can do for us. I think that's all I was going to say. I feel like I had one more point, but now I forget.
Do you have anything to add, Jonathan, to that?
I'd say, so Department of Defense engages with the Buy Clean initiative, as Kelly said, with the CEQ. And so there are a lot of things that Department of Energy, EPA, GSA, Department of Transportation are all doing. And we're trying to avoid gaps and overlaps. I mean, it makes no sense for us to both spend money on the exact same research project. So learn from each other, share knowledge. There are lots of requests for information that are going out to industry. EPA has one open right now. They're doing webinars on as they start to figure out how to label products, how to turn EPDs into nutrition labels that might be stamped on every piece of timber or stamped on every piece of steel. And so there's a chance for industry to engage on that, for academia to respond to that. Through labs such as ERDC, we're funding lots of initiatives. We're asking for support on pilot projects that are going on so that we can understand and have a consistency in the knowledge that we're gathering so that we can start to make policy decisions and figure out the best path forward.
And so Robert and Kelly, what is ERDC's role in all of this? So why ERDC, and what is ERDC's role in sustainable materials moving forward?
You want me to start? So I think ERDC as an organization in support of the Corps of Engineers and all of our sponsors and stakeholders, whether it's Army modernization or the Air Force or the Navy or really any agency you can think of with equities and infrastructure and environmental topics. We've been doing research for quite a while. And so, I think there's a unique combination of competencies between engineering, life sciences, environmental sciences, that can be brought to bear on these types of problems, and unique opportunities to leverage across civil and military as well. And so really when you look across the federal government, there's many agencies that are working towards this, but I think our strong understanding of DoD mission and how we deliver these construction projects, really combined with our expertise capabilities is key to supporting these kind of initiatives. And kind of folding back to the previous question about connections to the broader community, to industry and academia especially, I mean, that's something that we focus on in almost every project that we have. And so, we know that there's mid-technology readiness level material technologies that are out there in industry. Maybe those are things that have even been developed through investments from other agencies. And so we want to see, are there ways that we can leverage those to take across the finish line through more applied technology demonstration projects? Are there ways that we can connect those technologies to our districts to implement in projects? Right? But then I think one of the key things when we look at more early applied and fundamental research is partnering with academia. So kind of what are the best next generation technologies coming down the pipe, and how can we kind of plant the seed, put a bet on the poker table for the things we think are the most promising. And so ERDC has a lot of unique contract vehicles and unique partnership mechanisms that we utilize to do that, especially with academic partners. So that's something we're trying to integrate into our programs across the board, really to fill some of those key knowledge gaps that we need for DoD. I'll pass it to you, Stephanie.
ERDC is in a really good position to transition a lot of stuff. We're doing this with ultra high performance concrete, transitioning materials that were traditionally for military engineering applications over to civil works to use in these really mega big concrete projects. So, and Robert's done a good job here of making sure that everybody, all of the researchers that are working on this initiative for whomever, that we're all talking to each other and leveraging what we know. So that's
building a community that
Right.
is talking to each other to solve these hard problems. So I want to remind the audience we are now taking your questions since you've had time to think about them. And so our first question is to Robert, and this person asks, what led ERDC to begin studying sustainable materials in the beginning?
So that's a good question. So as Stephanie mentioned, we have been doing things that I think provide benefits in sustainability and reduced emissions long before I was alive. But in the Corps of Engineers, I think when we largely look at how we use materials and optimize design in our projects, sustainability is in direct alignment with reducing costs, reducing waste of materials, and all of that is done through material selection and optimization and design. And so I think the best example, I use this example all the time, is our work in mass concrete for, since the early 1900s, even late 1800s, but largely early 1900s to maybe the 70s, if you look at those concrete mixtures today, they are the most sustainable concrete mixtures you'll ever find, right? But we weren't ever doing that because of those types of drivers. We were doing it because of economics, right? And controlling heat and some of the other requirements we have there. So I think a lot of the things that we do in supply chain, contested logistics, using indigenous sources, cost drivers, I think are in strong alignment with sustainability requirements. And then we've seen over the last 15 to 20 years, those coming into the fold more as direct drivers rather than indirect benefits, I guess I would call it. And so a lot of that, as Ed mentioned, is starting with energy and building envelopes and things that we can use to reduce operational emissions. And now coming into specific drivers, particularly with a lot of advancements in chemistry and manufacturing that are really enabling us, I think, in the future to kind of change the paradigm of materials as we know them, and give us some other levers to further improve sustainability. So these recent initiatives have largely, I think, taken some of those drivers that have been there and elevated them to a level that we've never seen before. So the types of investment, the types of priorities, the direct connection between research to fielding those technologies into operational projects now and in the future, I think is really a result of a lot of these near-term initiatives with the new administration. And I would say even outside of the political sphere, the DoD is a global organization, right? And so I think a lot of the things we talk about, we're thinking here in the United States, well, we're building projects in Europe. And so we're having to react to what trends in the political side and industry in the European theater, right? Same in the Pacific. And so changes in Portland limestone cements, the emergence of mass timber, recycled plastics, and cold in place recycling of asphalt. There's all these technologies that even without those drivers we're having to adapt to because they're coming into the fold in our projects, whether they're here in the US or they're on one of our installations around the world, I guess.
Very good. Our next question is for Ed. From a USACE headquarters perspective, what will it take to change the way it does business to incorporate sustainable materials in construction projects?
So what I would first say is the UFC 1-20002 High Performance Sustainable Buildings has been around for about 10 years, about 2013. So sustainable building materials, there is a section and a requirement for there. Also, the UFCs have a lot of sustainable types of materials. We don't use high VOC paints. It's hard to use oil-based. I mean, they're all low VOC and acrylic. So that's what I would say is we have been doing it. But now to go further into the question is how do we change? How do we get this onto the construction site, get these materials or innovative techniques that are being researched or pushed through pilot projects? And what I would say is what's going to happen is once we're confident in the durability, the materials, the research that's been done, that it's been proven on a small scale, we scale up that size through either our guide specifications in criteria change requests or our UFCs. I really believe that once more policies come out and we have more information on the direction that we need to go, that will filter through multiple UFCs. We have plenty of UFCs that will be updated to incorporate those sustainable building materials, but it'll probably first start at that high performance sustainable building UFC.
That makes sense. So the next question is for Kelly. You mentioned the complex trade-offs that must be considered when thinking about sustainable construction materials. Can you talk more about how all of those factors are weighed and how you reach an ultimate decision?
Yeah, that's an excellent question. I think we're trying to answer it, but we're also recognizing that there is not a one-size-fits-all solution. There's not one rubric or metric that we can create that's going to give us the final answer. It's going to depend on the application and the location, by the building use, all those factors that I mentioned before. That's probably not a great answer. I know it's not really satisfying, but it actually should give us more hope of the ability to adopt these different these different nascent technologies and sustainable materials. Because if there was a one-size-fits-all solution, then what we're saying is everyone needs to develop the same thing, and then that's the answer. And as many of us know from years in this work, we're not going to solve sustainability and climate change with one big silver bullet. We actually need a lot of small solutions, and we need to chip away at it. So the fact that we can be hopeful that there's going to be a lot of different technologies that can be applied in different areas, hopefully that continues to provide hope and spur innovation in a wide variety of areas. ERDC is doing a great job at it. A lot of the other federally funded research labs are taking on some of these challenges. And really importantly, we are trying to measure and quantify the outcomes and not just put all of our money and time and effort up front into creating these pilot programs or stimulating the research. And so when we think about what is actually being weighed and what's actually going to be adopted in the future, it's really important that we have good records of every stage of the process. Science in general, research in general has a replication crisis. We also have a bit of a crisis of people not wanting to publish bad results or null results. And it's totally understandable why that happens. But the reality is that for those of us who are decision makers, who are trying to take the technology side, the science side, the engineering side, the architecture side into the policy world and go in and convince people to change the criteria, to fund a new program, to apply the results of a pilot project to a new policy, we really need to have a wide breadth of responses from every single type of project that's out there. So for example, some of the pilot projects we've been working on have been mentioned by the other panelists. Pilot projects, especially when you're building a military construction project or a civil works project, take years. They take years in the private sector and they take years in the government as well. And unfortunately, we can't wait 3 to 5 years for the results of that pilot project and then wait and see how the different materials hold up and see if the occupants enjoy their new building and then decide in 5 years, okay, we're going to adopt X, Y, and Z into our next set of projects. We are planning projects for FY26 and beyond. We have really long planning cycles, and probably everyone would cite a different year that they're working on right now. Some of us are working in the shorter term, some of us are working in the much longer term. And so that's part of this important, onus of responsibility on all of you researchers, that as you're researching, we need to know what is happening at every stage of your research, and hopefully you can communicate that to us. So if there's something really promising, we know that as soon as possible. Obviously, we need to be ethical about it, but if something is going well, if something's not going well, the more we can communicate on that, the more we can break down these silos between different parts of the government, between government and industry, the more we'll be able to adopt things sooner rather than later. And then maybe we can work towards answering that question a little bit better. Like, what are the trade-offs between these? How do we choose the best material for the best use?
So our next question, audience question, and any of you can answer this. So this person says, it seems as far as building materials out in the battle zone, tents are used. So looking for a material that will take any bullet and ordnance and yet be flexible to move quickly and set up. Also, would this material be good for vehicles to withstand any ordnance on the ground for ground troops?
I guess I can start with that. I think there's always an interest in improved material technologies for force protection applications. Whether it's concrete, as we've talked about, a lot of our interest in applications there is in more lightweight deployable systems like composites or combinations of materials. And I think if you look at the Army modernization strategy and really how the Army envisions fighting in the future in peer, near peer kind of conflict, the levels of protection that are required are going to be much higher than we've historically had to think about. And a lot of the concepts for operations there is the Army's always on the move, right? And so we're certainly back in strategic support areas and on our installations going to be building facilities and airfields and all of these things that we're going to have to project power and to provide survivability. But definitely on the front lines in the theater, lightweight, modular, deployable, not just build it, but also remove it and move it somewhere else is going to be a big driver. I think there are some connections there to sustainability and some of the topics we're talking about, but a lot of that comes into supply chain, right, and leveraging indigenous sources and fuel, right? We can have the most sustainable material in the world, but if we have to ship it from North Dakota to Guam every time we want to use it, it's not sustainable. And so I think that's another example of an area where sustainability drivers have a good overlay with mission, where we're trying to better leverage indigenous sources. So definitely a big interest continuing on lightweight materials with improved level of protection for deployable structures. And then as we get back to more permanent, enduring facilities, new materials there as well.
Very good. And so our next question, it probably be best answered by Stephanie, but anyone can answer. Are there any examples of new material being added retroactively to aging infrastructure that will lead to longer term sustainability?
That's very difficult to do. Especially, I'm going to talk about concrete. I'm going to talk about civil works and big concrete because that's mostly what I deal with. But it's very challenging in that respect because when you talk about things like surface penetrating sealers or coatings, like when you're looking at a massive element that's 40 feet wide and you want to put a material on that's so small and will barely affect what happens in the mass of that concrete. It's negligible, and that's a maintenance thing that you have to go out continuously do anyway. I don't know, there are some things that we can do to help our structures, but I don't think that there's anything retroactively that I can think of right now that would help sustainability, unless, I'm going to spin this a little bit because I think we've talked about new materials and developing new materials and materials, but there are a lot of things that we can do that you don't traditionally think about for sustainability. Durable, and I'm going to say concrete, but also all materials, durable concrete, durable materials, that's sustainability. If we have something that lasts for 40, 50 years beyond, some repairs that we use we're out there in the next 5 years repairing it. If we can just have good materials out there that last, that is sustainability without even doing any of what we've talked about doing.
Yeah, I think. Oh, go ahead, Ed.
Oh, I was going to say, like with our Milcon projects, with a lot of our renovations and things of that nature, we typically upgrade windows, we seal the buildings better, we add insulation. There are a lot of things that we utilize, and we have a whole process of deep energy retrofits and how we apply deep energy retrofits to existing building stock. And I think in the near future, we will probably see a lot more of those renovations for sustainability and trying to reduce the EUI of those specific buildings. So we do have technologies that we have been utilizing. We have been utilizing things like EFIS overlays and panelized construction or energy replacement of windows for energy reasons. So there are certain things that we are already doing on our installation.
Very good.
I think the thing I wanted to elaborate on, because I think it's a really important point in this space, is it really brings into importance life cycle factors, right? And so a lot of the things we talk about are reducing embodied carbon or whatever buzzword you want to use around it, for the initial emissions associated with manufacturing and what we're using in that material. When we think about our existing portfolio of infrastructure, anything we can do to make it last longer for the existing portfolio or ensure that longer durability of new infrastructure helps us to reduce those life cycle emissions, right? So I can take a dam and retrofit it with composites or something that extends its life double, and I've automatically reduced my life cycle emissions by half, right? And so I think we need to do the best things that we can on all of our new projects, but we know that we're not going to be able to afford to replace our existing projects with new ones that just happen to be more sustainable. So I think that's where we really have strong alignment with asset management goals on the civil side of our portfolio and military when we think about sustainment of facilities and infrastructure, where anything we can do to extend those projects helps from a sustainability perspective. And there are a lot of advanced material technologies as well as building systems and things that play into how we would do that.
So where do you see sustainability, these sustainable materials, where do you see this in 5 to 10 years? Like, where do you see the pathway to meet the goals that you're trying to meet?
I don't have a complete thought yet, but I'm going to work through this. So in 5 to 10 years, what I would hope is we start collecting the information, we start collecting the data, and industry starts looking at how sustainable they are, along with us looking at how sustainable they are. So our inspections might include reviewing EPDs or something of that nature, some sort of submittals or information that we're gathering from the manufacturers and from the construction contractors. So I believe that we will start tracking this information, and we will have a better clarity of what type of sustainable materials we're receiving. And I think we will be changing our specifications to being more sustainable and leading our designers to be utilizing more sustainable building materials. But it's really that I think in the next 5 years, we will learn a lot about what America can produce, what the manufacturers are producing, and how we can have a even playing field for everybody to bid projects, supply their materials, and move forward all the way through construction.
Very good. And another question we have from our audience is, philosophically, is coal fly ash offsets of Portland cement a net carbon reduction measure?
I think that's meaning, I think it's asking if we're using coal fly ash, are we reducing the
Yes.
CO2
Yes.
of the Portland's?
Right.
Well, yeah, because I mean it's a byproduct, and as long as we have coal-fired plants, we're going to have that byproduct. Using a byproduct for something that actually improves the concrete and makes it durable. Instead of Portland cement. So it's less Portland cement that we have to produce. And now with Portland cement, of course, we're transitioning from the type 1, 2 over to PLCs, Portland limestone cements, or type 1Ls, and that's helping in that too. But that leads to other challenges. If we have the type 1Ls, we get calls and emails all the time asking, how is this going to affect for mass concrete? How is this going to affect the heat of hydration, the durability against our deterioration mechanism? So, I mean, with every new material comes a new challenge. But to answer the question, I don't know that it would be net zero or net negative, but it does reduce.
It does reduce it.
I think philosophically, if we are going to produce those materials and if we do not beneficially use them, they're going to be landfilled. So that's just sunk embodied energy that's just wasted. If we can beneficially use them in something like concrete or fills or some other application, and it provides engineering benefits and allows us to reduce the amount of the high emitting materials in those products. And one of the other benefits is they're certainly more durable. It's kind of a win-win. Now, I do think that as we track and see diminishing sources of those materials, we're never going to burn coal to make fly ash, right? We may calcine clays at a lower firing temperature than it takes to produce cement, which is a lower energy process, and then use those as a replacement for fly ash. So I do think we're kind of in this intermediate phase where changes in energy markets are going to impact how we beneficially use some of those materials. So I do kind of see it as a gray area long term in how we quantify that, but at least in the near term, benefits of using those in something like concrete. Sorry, Jonathan.
I was going to say, fly ash is a byproduct, it's not the main product, and it shouldn't slow down our energy transition. So we're moving forward to cleaner sources of our energy, but it has helped to offset that, to avoid landfilling, to use a product in our concrete. So just remember, it's a byproduct, and as Robert said, it's not a reason to run our coal plants just to produce that.
Right. So earlier, Jonathan, you spoke to us about supply chain issues. How difficult is it to work through supply chain issues? How do you see us overcoming those challenges?
Well, I think our biggest problem with the supply chain is just understanding all of the folks that are involved in the process, all the industries that are involved in the process to just get us, one building, or to get us one vehicle, or to get us one product. And so, I think, as Ed said, in 5 to 10 years, that's where I see us, is having greater transparency among our environmental impacts so we can make better decisions. We don't need new materials invented in 5 years. We just need to understand what the footprint is, how much embodied energy, especially how much embodied water. We haven't even talked about water and the amount of water it takes. We just had a water day last week, and it takes a lot of water to make our products. And that's going to be another resource that there's going to be competition for worldwide. And so as DoD is looking to be more resilient and to reduce our environmental impacts, it's to also not compete with the rest of the world, to not compete with dwindling resources, because then people fight. And then when people fight, the DoD has to operate, and then we burn more fuel and we put more people's lives at risk as we engage on those scarcity of resources. So it's already been mentioned, we have very big dams, we have very big civil works projects, but we have hundreds of thousands of buildings that are in existence right now.
Yes.
As Robert said, focusing on what's existing, what already has embodied water and embodied carbon and embodied energy in, how can we preserve those? How can we make those last longer? How can we do deep energy retrofits? That's our first choice, is to make use of the embodied nature of those materials already. New buildings is glamorous, and new materials is glamorous, but making some things last a little bit longer is going to be better. And then right sizing. Do we need as much as we have right now? Does that serve our mission? Can we adjust? Can we build the right things when we have to build them? And then figure out the trade-offs between the materials. You can build a superstructure out of many things. What's the right product for the right location, based on transportation, based on installation, based on its full life cycle? Designing for disassembly. How do we put that back into the next building? How do we go cradle to cradle? So all those things have to happen before we just swap out a material for a better material. That's important, but there's a lot of things that we need our partners in industry, our partners in the architectural, engineering, and construction communities to help us with before we get to the part where it's of an easy plug and play of just a better material using a better energy source.
Very good. Thank you, Jonathan. The next question is, what research is ERDC conducting, so this may be for Robert or Stephanie, on tools to track and compare a material's carbon footprint, embodied energy, and carbon sequestration? And does this research include analysis on prioritizing the tool's benefits to the DoD?
So that's a good question. So it's another space where there's a lot going on across multiple areas of investment. We're trying to leverage as much as we can, and that's on how do we leverage what even looks right for an environmental product declaration for different applications, different classes of materials. So thinking through that in some of the key applications that we have in the DoD. And that's just the initial step of getting some of the primary data, the primary parameters. Then how does that feed into a life cycle analysis? And there's multiple of those out there on the market, and they're all kind of advancing in parallel. And so where do we want to hone our investments in concert with our other agency partners to look at what are the tools that we need to fold into the criteria updates and things to put the best tools that meet our needs on the menu. So we are making some investments there in research and development, internal activities here at ERDC, and a lot of activities with industry and academic partners, NGOs, organizations representing different industries, to try to get some of those tools. And I think the vision that Ed laid out, where these things are probably going to be integrated into future updates of kind of our overarching criteria related to sustainability. And then those tools will flow down into all the applications, whether it's buildings, whether it's airfields, whether it's port structures, to have ideally a standardized set of tools and standardized set of parameters across different classes of materials that we would use.
That makes sense. And so the next question, let's see if I can find it. It went away. Does the Department of Defense or USACE include carbon capture, utilization, and storage CCUS for concrete in any project specifications?
I'll take that. So we have not yet. We know that's technology. There's lots of vendors that have come and talked to us about how they can capture it at one of their industrial plants and put it into our materials to sequester it for a longer period of time. At the same time, we're also getting a lot of interest from industries who would like to store carbon underneath our installations and underneath federal lands and pore space. And so it's kind of a twofold question. There's geological sequestration, and then there's the material side of sequestration that we are interested in, that I think we'll be doing some more investigations and research into, but there are no projects yet that have set that out as a goal of let's offset ourselves by sequestering some maybe industrial byproducts into our materials.
And I think that the life cycle part of the equation, even in our existing projects, carbonation processes happen all the time, right? So we really don't even have a way to quantify at this point carbon uptake and sequestration in our existing airfields and pavements and bridges and all of these structures. So I think the calculus behind doing that across our existing facilities and then applying that towards emerging materials that may, take advantage of these industrial byproducts is something we're definitely interested in. In the near term, there's certainly some products that are of interest. I think when we talk about the 5 to 10 year time frame, some of the investments being made in materials that I wouldn't call them radical, but they are very different than some of the things we might call normal concrete today. Which I think bring in requirements, and would we even design this the same? Would the same design equations work for that? And so I think those are subject for longer term research. The other thing I wanted to highlight is I think those areas are areas where we see a lot of things that are probably not unique to the DoD, and so Department of Energy is making huge investments off the scale in this area. And so we're really trying to work across the federal government to coordinate with investments being made by other agencies with the private sector that I think in the long run can provide benefits in this space to the DoD as well.
And so we have a question for the group. Is anyone else excited about the recent discovery of the Roman self-healing concrete? Romans made their concrete with quicklime, which is lime in the pure state rather than a more typical slated lime, and it gave it a self-healing properties.
Yes, but I don't know the application. I'm excited to read a lot of the articles about they've cracked how they created that technology, whether it be through heating or other principles of the type of mixes, I guess, with concrete. But I don't know if we have a good application or we're researching it yet. Talk to you, Robert.
We're tracking that work. It's been going on for 10 years, studies related to that, and we've collaborated with some of the academics in that space. I think we even have some ongoing collaborations there. It's definitely interesting. I would say a lot of the things you look at in those mixtures that when we say, why are they so durable, we're doing a lot of the similar things with different manufactured products today. And have different requirements for how we would deliver a project. I would hope we would deliver a project differently than maybe the way the Romans would. But I think some of that recent work is really interesting. Definitely some of the insights on self-healing mechanisms, that how they work in some of those, which are not maybe what we would typically think about, are pretty interesting. So we're definitely tracking and aware of the work in that field.
So last question, and we'll ask each of you to respond. What are some advancements in this field that you're most excited about? We'll start with Stephanie.
Personally, I'm pretty excited about looking at waste products that don't necessarily get utilized, so byproducts. We've looked at recycled glass, people have looked at recycled glass, and like I mentioned earlier, I'm not sure that its application is going to be mass concrete necessarily, but things like that, where there's a waste stream that we haven't tapped into. I think that's exciting.
I'm excited about the math that's going to come out of this. And the reason that I say that is,
That's such a geek answer.
Sustainable building materials have been around for a while. We've been speccing low VOC paints. We've been putting fly ash in our concrete, and I know it went into a lot of mixes on my projects in 2003, 2004. The math of how do we quantify how environmentally friendly our construction is, I don't think we have a good grasp. What are we doing right now? How well are we doing right now? I don't think we know. So I think in the next 5 years or so, we will have that math. We will have that whether it be environmental impact calculation or something of that nature. We'll have a scorecard or something that says this project did this well, or quantifies how great our projects are. Because I already think that we've been doing sustainable building materials for a long period of time. I mean, even what you talked about, like the early 1900s, we've been doing that. But having that documentation, I think, is interesting to show the decisions that we make. And understanding how greatly we achieve our goals for sustainable materials.
So I'm most excited about the collaboration that's happening in this space. You know, industry is challenging industry to raise the bar. We're challenging folks to do better. You know, we've been building buildings for a very long time. We've been putting things in the ground for a very long time. You can kind of fall into the same old practices, and sometimes you need something like this to come along and challenge you a little bit. But the engagement we've had at DoD with other agencies, as we talked about kind of DOE and their carbon capture hubs, has reminded us that to do our part, because we build more than just about everybody, we need to look at source reduction. We need to look at ways that we can just be better. And so it's been good to collaborate. It's been good to be challenged. It's good to look at things with maybe a fresh set of eyes on each one of our projects.
Kelly, what are you most excited about?
Yeah, I'm excited about extended producer responsibility, and this kind of extends from what Stephanie and Jonathan said, but the idea that producers are now taking more responsibility for their waste streams and then also their products. So I think there's something that comes to mind is there's a lot of great flooring companies that do different types of like carpet applications, tile applications, where they're reusing a lot of those same materials. They come and they pull up the carpet after however many years, and then they extrude it back into plastic, and then they recreate their carpeting. I think there's a lot of great applications in different areas, especially plastic-derived items, which is becoming a bigger and bigger issue. And so I know we're not really focusing on that because plastic is not the best construction material, but it does have application in buildings. And so the more that we put pressure on producers to take responsibility for the entire life cycle, the cradle-to-cradle nature of their products, I think the better. And then this is a slight deviation, but I do think that there's a lot of excitement around, for me, that what I have seen on like social media and different younger person sites, which I'm not going to claim to be like a TikToker, but there's a lot of people speaking out against things like fast fashion and the carbon footprint from some of these things that we've taken for granted. And so I know it's a step away from what we're talking about today, but it excites me that more people and younger people are recognizing the carbon footprint of industry and the items that are being produced and the items they're purchasing. And I hope that that just scales up and snowballs into an even bigger impact when it comes to buildings.
So Robert, what are you excited about?
I guess if you know me, I get excited about most everything except for paperwork. So I think one of the neatest things about this work is, given that it's materials, everything is a material. And so from a materials researcher perspective, it's been pretty fascinating, I think, to look across all these different applications, all these different mission areas, maybe how we can provide positive impacts in some of these initiatives. So that's been exciting. And I think the thing that is the neatest about it is we work a lot of projects here at ERDC or in the Corps that are very unique, right? Nobody else cares about them except for us. But this is not that kind of a thing. And so I think the ability to work across different disciplines, so I don't think I've ever worked with economists and sociologists and environmental science people the way that we're doing in some of these programs. We've never had the kind of interagency coordination for this kind of whole of government approach to sustainability and resilience. And I don't think we've ever had, we've definitely had the interest, but probably not the resources to partner with the private sector in the way that we're trying to do to leverage new technology. So that to me it's very challenging, right? Because you're juggling all the time and trying to keep everybody coordinated because we're not we're not moving in sequence, we're all moving in parallel trying to make progress. But it's very exciting as a researcher for sure.
So for our audience, if you are watching the rebroadcast of this or even watching right now and you didn't have an opportunity to submit your question, we will continue to take the questions. You can send a request for information to erdcinfo@usace.army.mil, erdcinfo@usace.army.mil, and we will answer those questions for you in the future. I want to thank all of the panelists for being here today. And Kelly, this has been a wonderful discussion on sustainable materials, hopefully the first of many as we move forward in this space. Next month, we will be back right here, and we have several topics coming up. Between now and then, if you want to learn more about some of ERDC's exciting research, you can always go to the poweroferdicpodcast.org for our latest podcast. Until next time, find your joy. See you next month.